Let's look at our first game. Just as a reminder, we'll be working off the June 2007 LSAT, since that test is available for free as a sample on the LSAT website. We'll start with the introductory setup paragraph, since that'll give us an idea of what sort of game we're looking at. So the problem goes as follows. A company employee generates a series of 5-digit product codes in accordance with the following rules. So that doesn't tell us a whole lot. There's not too much to be done with that initial setup, but we can at least put a little bit of a schematic to say, what is this going to look like? We're going to have something that just looks like this. Very simple, just 5 digits lined up. So we can't do a whole lot more with that until we know what sort of game specifically we're dealing with. And to figure that out, we're going to have to look at the rules. So the first rule says that the codes use the digits 0, 1, 2, 3, 4, and no others. So at least now we know that what we're going to be putting in these 5 slots are the digits 0, 1, 2, 3, and 4. Still doesn't tell us a whole lot about what's going on. The second rule says each digit occurs exactly once in any code. Okay. So we can say each digit once. Again, not really sure where to go with that up front. The third rule says the second digit has a value exactly twice that of the first digit. Again, at least we can write that down so we have a complete checklist of rules here. And it's important to keep an entire checklist of all the rules, even if something seems trivial, because one of the major challenges with the logic games is just to keep track of all the information that you have at your disposal. So if you ever get stuck with a question, if you've written down all the rules, you can at least say to yourself, okay, which one have I not used for this question, and at least have a starting point for getting yourself out of whatever trouble you've gotten into. So we can say here that the second digit is equal to 2 times the first digit. And as we see, that's at least going to limit the possibilities for the second digit. The last rule says the value of the third digit is less than the value of the 5th digit. So we can say the third digit is less than the 5th digit. Now we're going to want to have some way to show this in a more concrete fashion rather than just writing down the rules and having this little diagram. Because one of the things that's key in any LSAT game is effectively using process of elimination. So in this case, what we can do is we can draw a grid and have a very explicit way of representing our yeses and our nos according to the rules that we have set up here. And we can do that as follows. So here I've drawn a very simple 2x2 grid that just gives us a way to represent things that we're ruling out as options, and also a way to represent things that we've decided that we know where to place so far. If you'll notice here, because we're only using the digits one time and we have 5 spots for 5 digits, this is essentially a sequencing game in a way, because all we're doing is arranging a sequence of these 5 items here. But it doesn't entirely make sense to think of it that way because we're not specifically given any relative information about before and after. We're given information specifically about the different placements here. So the next step, once we've written everything down and we have our little picture, is to say, well, if we go through these rules, how can we put that information into a more compact form that'll help us directly with the questions that the LSAT asks? So here we see, well, we're using the digits 0, 2, 1, 3, 4. Well, that just told us what goes on one axis of our grid. So we're using each of the digits once, and we have a 5-digit code. That just means that we're going to have 1 yes in each row of our grid, and 1 yes in each column of our grid. Because the 0 is only going to go in one spot, for example. And for example, there's only going to be 1 of these digits in each of the different positions. If we want to explicitly represent this on our grid, we can just put 1s everywhere to remind ourselves that there should be 1 yes in each row in each column. It's not totally necessary because this is sort of what we assume is the default, But that idea is important to remember in case we want to use it for something that doesn't have such a simple setup. Here we said the second digit is equal to 2 times the first digit. Well, this puts limitations on both the second digit and the first digit. And we can figure out what those limitations are by asking ourselves a series of yes or no questions if we get stuck. So we can say, for example, can the first digit be 0? And that answer is no, because if the first digit is 0, then the second digit is 0, which breaks this rule here. So we say, well, we can actually cross that out as an option. We're going to represent our definite no's as x's. We're going to represent our definite yeses by just filling in the box, and we'll leave the open spaces for our maybes. So you say, well, the first digit actually can't be 0. So can the first digit be 1? Well, if the first digit is 1 and the second digit is 2, that seems to be okay so far. Can the first digit be 2? Well, if the first digit is 2, then the second digit is 4. That seems okay. Can the first digit be 3? Well, that would make the second digit 6. There is no 6. So you can actually rule out 3 as the first digit. We can rule out 4 for the same reason. Now let's think about what restrictions this places on the second digit. So we already sort of talked about that, but let's make it more explicit. So the second digit cannot be 0, simply because the first digit couldn't be 0. The second digit also cannot be 1, because that would mean that the first digit had to have been 1/2, and that doesn't even make sense. The second digit can be 2, because the first digit could be 1. 3 is problematic for the second digit because we can't satisfy this rule. And 4 is okay for the second digit because we can still have 2 as our first digit. So we've narrowed this down a decent amount. And as you're going through this on the test, this is something that once you get used to it, you'll be able to apply very quickly and just go through and X out what you need to X out. We only have one more rule to contend with here, so that the third number is less than the fifth number. Again, this puts restrictions on both the third number and the fifth one. So the third one is the one that has to be strictly smaller than something else. So we can actually rule out 4 as an option. Because if the third digit was 4, then the fifth digit would have to be greater than 4, which again is not an option. Similarly, we can say that the fifth digit cannot be 0, because then there's no way for the third digit to be less than him. So we get a little bit more of a restriction on our mapping here. And as a last point, you just want to take a few seconds to look and see if there are any particular rows or columns that are especially limited at this point. And you'll notice the first 2 digits are pretty limited because there's only 2 options for each of them. And they're actually linked together. Note that these 2 guys are linked together. And these 2 guys are linked together. We don't know anything about our 4th digit yet. So we can start looking at the rows and say, are there any rows that are particularly limited? And you'll notice here that the 0 can only go in either the 3rd spot or the 4th spot. These aren't things that are important to write down, but they're important things to note because they're probably going to become relevant as we start looking at the questions. So the next thing we can do now, once we have as much done as we can here, is in fact go to the questions. So let's do that.